So continuing on with our second section, we are going to solve systems by substitution. Now, this solving system by substitution is basically just another way of, instead of having to graph things, we can also just do things by using the equations. Or in other words, it's solving something algebraically. It becomes much more beneficial because there may be some situations if we were to try and do a Cartesian graph, and if we have two lines, well, their point of intersection may be, let's say that one, let's say it's negative 1.5, negative 3.275. Well, that's going to be really hard to look at if you're trying to graph. But if we do things algebraically, so by substitution or the method that I'll teach you in section 3, it becomes a lot more precise. At the same time, it solves us or supplies us with some of the skills for some of you, if you're going to be going on to universities into some of the higher mathematics, it allows you to help solve matrices. Now, it's taken out of the high school or Saskatchewan high school curriculum right now. It may come back later on. Some of your parents may recall the word, but that's fine if they don't. I'll be showing you how to do substitution. Now, the main part that we're going to be doing is getting either one of the variables alone. You have to get one of the variables alone. So these are some three steps that I like to use. First step that we use is substitute or replace one equation for a variable in the other. Solve for the one variable, and then we solve for the other. So what does that mean? Well, that means this. It doesn't matter which equation I use. I will absolutely show both ways because either of these, the equations will work. So for example, if I label this equation 1 and this equation 2. Well, in equation 1, one of these variables is going to be a lot easier to get by itself. Hopefully you can see that that's the x. So if we do have an x add 2y equal to 5, the easiest variable to get by itself would be the x. So in order to do that, we would subtract 2y from both sides. Now, by force of habit, I like writing my variables first. So I can write negative 2y plus 5. So as soon as I've gone one of the variables alone, I can actually start using my steps for substitution. So substitution is literally substituting or replacing one thing into another equation. Now, if this is saying that x equals negative 2y plus 5, I'm going to plug that into the other equation. So I solved equation 1 for x. So I'm going to plug this equation into the other equation. So I'm going to substitute equation 1 into equation 2. Now the beautiful thing, or the thing that we're looking for, is we have x equal to something. X equals negative 2y plus 5. Well, in this equation, in equation number 2, we have x subtract y equals negative 1. So the equation says x equals negative 2y plus 5. Well, if x equals negative 2y plus 5, I can just take my negative 2y plus 5 and put it in for the x. Everything else in this equation has to stay the same. As soon as I'm done with that, then I can start using my general rules for solving. For example, combining my like terms, I can combine my negative 2y and my negative 1y to give me negative 3y. And then to get the y by itself, we would subtract a 5. Negative 3y equals negative 6. And therefore, after that, divide by the negative 3 to get the y by itself. And y equals 2. So without me actually going through, and I apologize, without me going back through these steps, I've already substituted one thing into the other equation, and I've solved for one of my variables. In this case, I've solved for y. So I'm done 2 steps in a very short amount of time. My last step is I have to solve for the other variable. So if y equals 2, I'm going to have to plug 2 into one of these equations to find out what x is. The beautiful thing, though, is it doesn't matter what equation you do. I could plug this 2 into this y, into this y, but at the same time, it makes almost more sense to plug it into this y. The reason I like using this one is because it already has the x all solved for. X equals negative 2 times your y at 5. Well, if that's the case, if I take, just grab the wrong thing, my x equals negative 2, no, I'm sorry, I'll just erase that for a second. Equals negative 2y plus 5. If my y equals 2, I can substitute that one in for my y. And then quickly solve. I know that negative 2 times 2 is negative 4. Add 5, and x equals 1. The last thing I like doing, though, is using an ordered pair. Now, just like when we're graphing, we want to make sure that we are identifying what point is this crossing. So if we do tie it back into our section 1, we're talking about where do 2 lines cross? Well, 2 lines cross at an ordered pair, x, comma, y. And in this case, our ordered pair is 1, comma 2. Now there is a reason that I wanted to show this. That's why the reason that I showed all of this as being so left-sided is because it doesn't matter which equation I use. If I take equation 1 or equation 2 and I solve for one thing or the other, I'm all set. For example, if I used equation 2 and I have x minus y equals negative 1, if I were to, say, solve for y. Now, some of you may add the y over and add the 1 over. Some may subtract the x, leaving us with a negative y, and negative x subtract 1, divide by a negative 1. Of course, when we're dividing by that negative 1, we divide everything by that negative 1. Y equals x plus 1. It does not matter which method you use. As long as you are showing your work and you are doing your work correctly, you will be fine. So I've manipulated, got one thing by itself. So now that I've used equation 2, I'm going to take this. I'm going to take this y, which is x plus 1, and I'm going to take that from this equation 2, and I'm going to plug it into equation 1. So if I go back to equation 1, which is x plus 2y equals 5, if y equals x plus 2, I'm going to plug x, sorry, not x plus 2, x plus 1, sorry. X plus 2y equals 5, I'm going to take my y which is x plus 1, and plug it in for y. Which means I can then go further. And at the same time, I make sure that I do my distribution correctly. Sometimes I have to double check, make sure it still should work. And then I can combine my like terms. I have 3x plus 2 equaling 5. Get the x by itself, so I can subtract 2. 3x equals 3. And divide by the 3. X equals 1. From there, I take my x equaling 1, and I plug it into one of my equations. The one I would probably suggest is the one that already has the y solved for it. Well, y equals x plus 1. So if y equals x plus 1, and I know that my x is 1, 1 plus 1 is 2, which makes my ordered pair 1, 2. The exact same value. So it's not any different whether you do it one way, whether you go solve one equation, or you do the other way. At the same time, I could solve 2 other ways by getting this y by itself on this equation, or I could get the x by itself here. I just have to add the y over. There's literally 4 different ways of doing this, and they're all fine. So let's do a few more examples. The reason I do more examples is because I do teach a few skills, especially ones that some people don't really do in grade 9, but I for sure did. But they're skills that are really necessary to be successful. Now, I'm not going to use all the time and show 2 ways for this. I will just stick with one, just letting you know that you can do it 4 different ways, especially if you have 2 variables. So the question in B is, well, let's say we have 5x subtract 3y equals 18 and 4x minus 6y equals 18. Well, that's going to be tricky, because our entire objective first is we need to get one of our variables alone. Either of these equations, it's going to be difficult to get either the x or the y alone. You just have to go for it. And of course, I review lots of skills. Remembering, I love fractions. Yes, I know that you just internally groaned. If I use equation 1, if I use that 5x subtract 3y equals 18, just so you know, there are some professions that prefer solving for an x and some that prefer solving for a y. For our initial take right here, it doesn't necessarily matter which one we solve for. The traditional way that we would usually do is we usually get a lot of y's alone, especially in math. When we get into graphing our lines, we want to get the y by itself, because our favorite way of graphing is our y equals mx plus b form, our slope and intercept form. Now, all of that really doesn't matter when we're just using solving equations. If we're going to solve it algebraically, especially for the fact that we're only dealing with linear, it's all fine. When we get into pre-calc 20, it's going to be much more beneficial to get the y's alone, because then we can do some more special things with that. But that's something that we'll worry about more next year. At the same time, it's not bad to get our y's alone. Now again, just like over here, I said that we could subtract our x and divide it by the -1. Another way that some of you may prefer to do is I can add a 3y and then subtract off my 18. meaning I'd have a positive 3y equaling 5x subtract 18. And after that, I can divide by my 3 to get one of my variables alone. We need them to be alone. So dividing by that 3, the beautiful thing on there is we at least only have one fraction on this. The bad news is, oh, not plus, sorry, that should be a subtraction. The bad news for some of you that don't like fractions is you're going to have to get comfortable with fractions. So now that we've manipulated equation 1, we can take our y, which is 5/3 x subtract 6, and plug it into this equation. And just before you go and start asking other things, if we manipulated this equation, let's see, we would move there over. That equation completely manipulated should be, I believe it, 2/3 x, probably subtract 3. Let's see, just give me a second. Yeah, we are all good. Now, the reason that we're not going to go through here is because it's going to be very difficult to try and graph some of these very accurately. Now, I know that for this one, we could start at our y-intercept of -3, go use our rise and run of 2/3, so rise of 2, run of 3. So just to kind of see a small little visual. We'd be starting at -3, going up to over 3, up to over 3, and connect the dots as a line. Starting at -6 on this one, going up 5 over 3. Absolutely, this one probably will cross at a nice point. It might not. I can't remember what the answer to this question is. That's why I need to solve it algebraically. Now, if I don't have the graph paper, and I do say, for example, using the algebraically term, you will have to solve things algebraically. Main reason is you need to be able to use your head. You need to be able to manipulate equations. It's a required skill that many of you will need for Pre-Calc 20, Foundations 20, and 30 level courses. If you're planning on going to universities, being able to manipulate equation is going to be a rudimentary skill. And that's what I'm trying to emphasize in this and encourage. You need to be able to use your head and use proper mathematical skills. All right, continue on. So plugging this 5/3 x subtract 6, we're going to be plugging that into this equation. Now this one for sure is not going to be the end of the world, because if I plug that into 2, and I have 4x subtract 6y equaling 18, if y equals 5/3 x subtract 6, wherever I see this y in the second equation, I'm going to write 5/3 x subtract 6. No, keep that as black for right now. I'm just going to get that a little bit higher. Oh, sorry about that. What we'll then work on is our general distribution. We can get things in, combine it. So 4x stays as 4x. That's not being distributed. It's our -6 that is being distributed. Now -6 is the same as -6/1. So -6 by 5 is 30. Being divided by 1 times 3 means I'm going to have a -10x. Now I can do that on the side. Just reminding, -6/1 multiplied by 5/3 means I have -30/3, which gives out -10. Our fraction skills cannot go to the wayside. Last thing, negative 6 times negative 6 is positive 36. Let's see, combining like terms, 4x subtracting 10x is negative 6x. I totally understand some of you would be able to manipulate and solve things one step at a time, or to do things like this. You could be able to subtract that 36 over in the previous step. Those are basic skills that I can understand you being able to do. If you go from this question and you just write down the answer, well, that means that you just copied off of a friend. It means that you don't actually understand things, and it's really hurting yourself. Kind of sucks. I mean, getting all of this extra stuff, being able to ask questions, and then just copying off of someone else. Doesn't sound right. Anyways, negative 18 divided by negative 6 is 3. So now that I have what x is, I need to solve for what y is. Again, I could plug it into any of these equations. I could plug my 3 into here, and then I just have to manipulate. I could plug my 3 into here and manipulate. But I have an equation that already has it solved for y. Y is negative 5/3 x subtract 6. If you're not liking the fraction, you don't need to deal with the fraction. At the same time, it's not the hardest thing to do. Because if y does equal a 5/3 x subtract 6, and if x equals 3, let's see, 5/3 times by the 3. Of course, still being conscious of the fact that we are dealing with fractions. 3 is the same as 3 over 1. Oh, and I can reduce my fraction right here. 3, 3, I'm left with 1 and 1. 5 times 1 is 5. And 5 subtract 6 is negative 1. So the point where these two lines would be crossing would be the point 3, negative 1. And tying back to that graph, 3, negative 1 would be the cross of that graph. Obviously, you can tell from my little sketch here, it's not very much to scale. If you were given graph paper, yeah, you'd be able to do that no problem. Now allow me to show you the situation and the practice as to why algebraically is a very beneficial method. We have an equation. Well, we have a whole bunch of fractions here. I'm going to show you, you'll also notice that they are the exact same equations. 1/2 x subtract 4/5 y equaling negative 2. Same thing over here. And y equals 1/4 x subtract 3/8. Both the exact same. There are two primary methods to working with these fractions, and I'll show you both. The first one is going the, I'll call it the hard way. It's not really the hard way as long as you understand fractions. The hard way is leaving everything as is. And if you leave everything as is, you'll be fine. Now the beautiful thing is this equation already has a y by itself. So I'm going to take my equation at y equals and plug it in for y. So my 1/2 x subtracting 4/5 y equaling negative 2, I'm going to take it and plug it in for y. My 1/2 x subtracting 4/5. Well, wherever I see y equals 1/4 x subtract 3/8. Same skills, we're just working with fractions. We do have to do a distribution. So our 1/2 x. Now I know that I can take my 4/5 x and multiply it by 1/4 x and get to negative 1/5 x. Just so you can see those skills, 4/5 multiplied by 1/4. 4's cancel off. I'm dealing with 1 and 1. 1 times 1 is 1. 5 times 1 is 5. But it's negative, so that's why I'm writing my negative 1/5. At the same time, I can take my 4/5 and multiply by the 3/8. I can reduce those. 4 and 8 reduce to be 1 and 2. Meaning, I'm left with a positive 3/10. Why is it positive? Because a negative and a negative is positive. So let's go through our basic skills again. Well, we have a term that has an x and a term with an x. So we're going to combine our like terms. Of course, we can't combine a 1/2 and a negative 1/5 and say, I don't know, what's something really wrong? Negative 3/10. 0 over negative 3. I don't know. That's not how we deal with fractions. If we're going to subtract fractions, we need a common denominator. Now, a common denominator between 2 and 5 would be 10. So I multiply by that funky form of 1. Multiplying by the denominator of the other one is one very quick way. Of course, in our next unit, I'll be showing you another way of getting that lowest common multiple. But no matter what, we have a 5/10 x subtracting a 2/10 x. After that, I can keep on going. 5/10 subtracting 2/10 is 3/10 x. Please don't forget that they are x terms, which means that we do need to keep our x there. Our last bit of work here is to get the x by itself, which means that we need to somehow get rid of this positive 3/10. So I'm going to subtract the 3/10. But if I'm subtracting 3/10, I can't just subtract it from 2. I can't have a negative 5/10. That's not right. Negative 2 is the same as negative 2 over 1. Get a common denominator. So I multiply by that 10 over 10. And now I'm working with a 3/10 x plus negative 20 over 10, subtracting 3 over 10. Continuing on, 3/10 x equals negative 3/10, negative 23/10, sorry. And continuing on, let's see, that's 3/10 times x. In our intro unit, we had done some skills with here. There's 2 ways of doing it. I'll just do a nice little review of that right here, right now. If I have 3/10 x equaling negative 23/10, and I'm just going to clone it. There we go. There's 2 main ways of working with it. Either we could divide by a 3/10, and since this is a grade 8 skill, 3/10, 3/10 cancel off, but dividing by a fraction means multiplying by the reciprocal, or as some of you like saying, the reciprocal. It works. Tens cancel off, and x equals negative 23/3. The more time-consuming way, but it still absolutely works, is I can multiply both sides by the 10, meaning that my 10s all would actually cancel off, and I have 3x equaling negative 23. Divide by the 3, and x equals negative 23 thirds. Same answer, two different ways of doing it. All right, but again, we're not finished because x equals negative 23 thirds. Well, we need to find out what does y equal. Looks like my stuff just moved slightly. There we go. Just gonna fix that. There we go. Everything's all good now. Yeah, that's so good. So we have what x is, and y equals 1/4 x subtract 3/8. So y equals 1/4 x subtract 3/8. Well, let's solve for what y is. If our x is negative 23 thirds, in both situations, which it always will, if you solve one thing one way and you solve it the other way and it's not the same thing, it means you did something wrong. But y is 1/4 multiplied by the x, which is negative 23 thirds, subtracting 3/8. So we can continue on. 1 times negative 23 is negative 23. 4 times 3 is 12. Well, I can't combine fractions unless I have a common denominator. A beautiful common denominator between 12 and 8 is 24, which means this one has to be multiplied by 1, 2 over 2 to give us 24. And this one will have to be multiplied by 1, which is 3 over 3. Us getting negative 46 24ths, subtracting 9 24ths, and our y value being a negative 55 24ths. Our final answer, as an ordered pair, as an x comma y answer, is negative 23 thirds. Sorry, comma, not finished, negative 55 24ths. There is our answer. This is where these two lines would cross. Now that's going to be very difficult to try and find out the exact answer for. Yes, you can approximate that as negative 7.6 and what do we got? Negative 2, what's even? Negative 2.3, even though it's negative 7.666666, you'll never say enough sixes to actually say the proper number, and negative 2.2916666, again, continuing on. This is an exact value. It's an exact fraction. It's a perfect rational number, which means that our answer is fully correct. Now, I said that this was the hard way. There is a relatively easier way of working with it. Now, the way is really, there's multiple ways of doing it. The overall easy way to do it is get rid of your fractions. Mr. Steinable, how do I get rid of my fractions? This is a skill that sometimes grade 9s are not privy to. At the same time, that's why I'm going to show you. It was done. It's for sure was done in the previous grade 9 curriculum. The old Bert Thiessen textbooks, which are still an absolutely fantastic resource, may not be used in many high school curricula or high school classes right now. Keeping in mind, a textbook is a textbook. We teach the curriculum, we teach an understanding. So the way that we really teach that understanding is we can get rid of our fractions. In order to get rid of our fractions, now, you guys, I have taught already. If I multiply everything by the common denominator, I'm going to get rid of my fractions. If I multiply every single term by 10, and I do mean every single term, all of those fractions will be gone. So in my first equation, 10 by 1/2 is 5. 10 by -4/5 will be -8y, and 10 by -2 would give us -20. I could technically do the exact same thing here. But now that I've gotten rid of my fractions here, I could take my y, which is 1/4 x subtract 3/8, which has that y all by itself, and I can plug it in for the y. 5x subtract 8. Y is 1/4 x subtracting 3/8. Well, that equals -20. Distribute 5x -8 over 1 multiplied by 1/4 x is -2x. -8 multiplied by -3/8 is +3. Right? Yes. No. Hold on. That's why I wasn't looking right. I forgot to write the negative here. So I can combine my like terms. 5x subtracting 2x, 3x. At the same time, again, this is what I told you before, you can do work at the same time. Get my x by itself, and x is -23 over 3. Now that I know what my x is, well, I've already done all the work. X is -23 over 3. Continue on with this work down here. The y will still be -55/24, which means that our answer is still going to be -23/3, comma -55/24. No matter what, we still get the same answer. Now, as you're looking at the assignment, if you do have your textbook, this is some fantastic questions to do. They have, for sure, the fractions. They have a lot of these substitution questions. If not, I am going to be posting some other work for you to practice these skills. Of course, still with the answers. So it would be very beneficial for you to practice. They're all good things to know and be beneficial. At the same time, I know that the thing that I've found doesn't necessarily have these fraction questions. So being able to still do these fraction questions is going to be a necessity for you to be successful later on. Alrighty.